Okay, I cleaned the unit up last night with the hose, the watering can, washed all the crud out of it. It's quite nice and clean inside now. It doesn't have that horrible stink of old ashtrays. Cleaned all the pots and things, got all the water out of everything, left it to dry overnight. I'm sort of on the final run now. Put all the front panel back on, as you can see. And what the plan is now is I've connected up to the dummy load, and from there what I'm going to do is do a power test and distortion test. The first thing I'll do is I'm running into an 8-ohm load with the Hewlett-Packard audio analyzer. I'm feeding at the moment. I'm going to feed in a 1 kHz tone and drive both the channels to clipping, and see what power figure we get first. And to get the power reading on this Hewlett-Packard, it's 19.0 special function. The right hand meter will now calculate volts and current and work out the power into 8 ohms. There's also a special function if you want it into 4 ohms, 19.04 special. That will give you into 4 ohms, basically doubles it. So it's 19.0 special anyway for the power figure. So what I'm going to do is I'm going to run the amplifier up, dual channel mode. That puts the most stress on the power supply. I'm going to run it up for a while, just check, make sure it doesn't get too hot, and then just make sure it sort of cools down again afterwards. So here we go, winding up the power now. So you won't hear anything because I've got no speakers connected. So that's at 2 watts, 3. You can see the on the scope the signal gaining. It's already at 70 watts RMS. That's at 70 watts RMS per channel. We're just running into clipping there. If you can see that top edge of this waveform just squaring off there. So let's bring that back, just back from clipping. About there, somewhere around there. So it's rated about a 50 watt amplifier, I think 45, 55 watts, something like that, but it's actually making 70 watts dual channel drive as well. So that's pretty bloody good actually. Quite a powerful amplifier. As you can see there, it's pulling 3/4 of an amp out of the mains. So amplifier looks good. It's warm. It's certainly not hot. It's not even. It's only very slightly warm as well. So leave that on for a little while just to prove the amplifier's okay. But that seems fine. What you can do now is you can go into distortion mode. And there we go. The distortion is good as well. It's 0.05% at 70 watts. You'll find that will rapidly increase as I push it into clipping. If I push it into clipping, you'll see the distortion go to the next range. There you go, 1%. So at 1%, it's making probably... So 1% distortion, it's making 81 watts. So that's a powerful amplifier, especially for its day. Let's turn it down a bit. I'll hold it right on its beam end. It's an old amplifier. But it's working really well. One thing I did notice, and this is quite an unusual fault, and it's probably due to the amplifier hasn't got any bandwidth limiting on its input. If I turn the high filter off and run the amplifier up again, I know there's a matching problem between the Hewlett-Packard and the amplifier itself, but you watch the waveform as I increase the power. See, the amplifier goes unstable, badly unstable. I mean, you can see it's jittering all over the place. Just before clipping, it's actually got better. Actually, it seems to, when it was cold, it was doing it much earlier, but now it seems to be only doing it on the verge of clipping. You see that instability? The waveform goes all blurred. It's just a very high frequency ringing somewhere. So leave the high filter on, just give it a bit of bandwidth. So that seems to be working really well. Amplifier's basically ready to be sold, I think now. That's one of the tests I do like to do. I do like to run them hard for a while and just make sure that it's going to work fine. If it's going to be sort of worked hard by, especially you sell it to a teenager or sort of someone who wants to buy a classic amplifier, who's going to put it under a bit of stress. That this is a good way of just proving that it's going to withstand a bit of abuse. Obviously that's only into an 8-ohm load. I could put it into a 4-ohm load, but I just don't think it's really fair on an old amplifier like this. Putting in a sine wave drive at 4 ohms, that's its worst case scenario really. So there we go. Distortion figures are really low. I don't know what the spec is in the book, but that's 0.05% is good by anyone's standards, to be honest with you. There's a slight problem with the instability on the front end, but that won't be apparent under normal conditions, I shouldn't think. Anyway, thanks for watching, and more some of these old classic amplifiers. I've got another one coming up that I used to have when I was a teenager. It's a Technics SU-3500, which is a really nice amplifier. Not as powerful as this, but as good amplifier, if not better. So yeah, thanks for watching, and hope it was of interest.